Hey everyone, happy Wednesday. I am back in New York, but bringing a little piece of Florida with me. It's my Fort Lauderdale shirt. I've got lots of these things, so Florida will never leave me. But here I am today, surprising you guys again on a wonderful Math Wednesday with the Learning Liaison. I hope you are ready for what I have in store for you. So let's get started. All right, question one is definitely a geometry question. Right? We can see that it is a middle and high school level type of question. And before we even look at the words on the page, we notice a lovely chart that they have. It's a graph, a lovely graph that they have depicted for us. So by just glancing at the graph before we even really dive in and get started, we notice that there are two lines. They have some type of intersection because they are crossing, and that intersection point happens to be 3, 2. So now let's go ahead and read the question and see what they're looking for. It says the lines to the right would be considered what? All right, they didn't really give us much to go off of, so let's read our answer choices and see what we've got going on. They tell us intersecting, perpendicular, parallel, and intersecting and parallel. So do you guys even know what these words mean? Because we can't move forward unless we actually define the words intersecting, perpendicular, parallel, and intersecting. Well, before I even dive into anything, let's go with some pretty simple terms. Parallel. That seems to be a pretty good one to start with, right? Well, if anybody knows parallel, I definitely do. I hope you do too. Parallel always helps me because it's not that bad. See those lovely two L's that are right next to each other? That's how I remember what parallel means. It's two lines, two L's that go up and down, and they will never cross or touch. They look just like railroad tracks, so it helps me also remember that railroad tracks are parallel. So parallel lines happen to be lines that do not intersect. This is always great to start with. Try to figure out what your answer choices are telling you because the question itself didn't give you much to go off of. So we notice that parallel means do not intersect, but then D says intersecting and parallel. Well, that seems to be something that can't exist because we can't have something that is crossing and not crossing at the exact same time. So D, sorry, doesn't seem like it's going to be a good fit for us. So let's go ahead and cross that one off, not even in the running. Now we're left with intersecting and perpendicular. If you know anything about perpendicular, I know a lot of people know that perpendicular lines look like this, and they generally create something special. That thing that's special is a lovely 90-degree angle. Well, perpendicular slopes, two lines that are perpendicular, also create a perfect 90-degree angle. So here we have intersecting slopes, so intersecting lines that create 90-degree angles. All right, but how do we know if these two things, these two lines, actually make a 90-degree angle? So we've got to know a little bit more than just what the terms mean. They actually have very specific things to them. So perpendicular slopes, let's talk about that. Perpendicular slopes happen to be opposite signs of each other and reciprocals. So opposite signs and reciprocals. What do I mean by that? So if the first slope, we'll call it slope 1, is, let's say, 1/2, then slope 2 needs to be the opposite sign, so it has to be negative, and the reciprocal. So we have to take our fraction and flip it. And 2/1 is the same as saying just 2. So now we know that perpendicular slopes are opposite signs and reciprocals of one another. Let's talk about parallel slopes. If two slopes are going in the same direction, at the same time with no intention of crossing each other, they're going to have the exact same slope. So parallel slopes are exactly the same. So slope 1, we'll call it S1 and S2. If slope 1 is, let's say, 4/7, then the second slope will be 4/7. And they can be whole numbers. It doesn't have to be fractions all the time. If the first slope is 7, then the second slope is 7. Now that we've covered 2 of those, let's talk about what intersecting means. So if you can remember perpendicular slopes and parallel slopes, then you have an advantage because you by default don't have to remember the last guy. And I'll tell you why. Intersecting slopes are simply not perpendicular and not parallel. So the cool thing about intersecting is if it is not perpendicular, it is not parallel, then it must be intersecting. So this is what I like to call the default, right? So if it's not the first two, then it must be this one. And it's very difficult to describe slopes any other way when we're talking about what they look like and they're doing stuff on a graph, right? So we go back to this and we actually need to figure out the two slopes of each of these lines. Well, there's a blue line and a purple line. So let's start with the blue line, all right? Well, I know that I can get to 3,2 because that is something that they told me. If I'm looking at the blue line, what do I notice? I notice that I have a perfect point right here at 0, 0. So to count my slope without using the slope formula, I simply go up 2 and over 3. So slope can be looked at as rise over run. So remember, I went up 2 and then over 3. So right now I have a slope of 2/3. Now let's say you don't like that and you'd like to use numbers. Not a problem. Let's go ahead and use the numbers. So I have 0, 0, and 3, 2. Don't forget you have to label them. So x1, y1, x2, y2. Don't forget, I can label it x2, y2 first, and then x1, y1, as long as I'm consistent. So the formula that we should be using is y2 minus y1 all over x2 minus x1. So go ahead and plug in what you know. 2 minus 0 all over 3 minus 0 to give us 2/3. Same answer as if we counted it, okay? Now, we still have to figure out what the purple line is, the purple slope. So the blue slope, I should have did that in blue, but somehow we ended up in orange. The blue slope is 2/3. Let's go ahead and do the same thing. I'm going to count and show you how to do it with a formula. So I see a perfect intersection here at 2, 0. And I need to go up and over to get to that green dot. So I'm going to go up 2 and over 1. So my rise over run is up 2 and over 1, which gives me a lovely number of 2. Well, if you don't like that, not a problem. We're going to use our points. And our point here is 2, 0 and 3, 2. I have x1, y1, x2, y2. So I plug them in. I know that I have 2 minus 0 all over 3 minus 2 to give me 2 over 1, which is the same as saying 2. Okay, so now we have our two slopes. And now we actually have to look at our two slopes to see what is going on. So slope 1 is 2/3, and slope 2 is 2. Well, they are definitely not the same, so we cannot say that they are parallel. And they're not opposite signs. One is not negative and one is not positive. So we can definitely not say that it is perpendicular. So the only one that we are left with to say that it must be is intersecting. So our winner chicken dinner here is A, intersecting. Now, let's just say, oh, if you have questions, I just forgot to ask. If you have questions, go ahead and put them in the chat. I can see that I have the chat box open, so no problem here. But let's say that they weren't asking about the slope, right? Let's go ahead and do a bonus part of this, and let's come up with an equation for the purple line and the blue line. So for the purple line, I'm going to call it line 1. And for the blue line, let's call it line 2. Okay, well, we already have a point, and I'm going to cheat a little bit. I'm going to cheat a little bit and go ahead and use the slopes from before. So while I'm on this, I see a question, and it says, can't you just answer by just looking at it? You want to be careful with that because perpendicular slopes still do intersect. So I'm going to draw to my best ability what a perpendicular slope will look like. That's a perpendicular slope. But if they turn it sideways, it may look a little like this. And you don't really know if it's 90 degrees or not, right? So you want to make sure that you're using the slopes of each line to properly have, like accurately have those slopes and not just eyeballing it. I know these are one of those things where it's like you look at it, but you don't really know what you need to do. So once you see it and you see the words and you understand it, then it all starts making a lot more sense. You're very welcome. So I'm going to take my purple slope, which is 2, and write it on the other page. So we know that this had a slope of 2, and the other one was a slope of 2/3. Okay, so if we had to create an equation, we can actually just look at this graph. Great thing about graphs. We would have still had to calculate our slope, but now what type of form does our line need to be in? Very specific. If you're on the other side and you're yelling at the computer or whatever you're looking at and you're saying y equals mx plus b, you are correct. Where m is the slope of the line and b is the y-intercept. Okay, so just like football, when people intercept, it's where it crosses through, right? So when we're looking at this, we're looking at where does the line cross through the y-axis. So if we're looking at line 1, which is the purple one, we look and we notice that the line crosses through the y-axis at -4. Well, that's really cool because all we have to do is say y is equal to our slope, which we calculated earlier, keep the x, and now write -4. Wham, bam, thank you, ma'am. That is your equation for line 1. Now go ahead and try it, but I'm still going to write it. Line 2, we're going to do the same thing. We're going to start with y equals our slope, which is 2/3 here. Keep the x, but what is my y-intercept? I'm trying to make a 0, and I'm noticing that this pencil doesn't work. It's a 0. So you can either write +0, or you can not write it at all because you kind of don't have to. So you can write the +0 or you can skip the +0. So let's recap. That -4 in the equation here is the y-intercept. Intercept. I don't know why I'm saying it's a thing. I just do it. So that is the y-intercept. So it is where the line itself crosses through the y-axis. So we're looking at the y-axis, and we know that guy is right here. This is a horrible line. All right, that is the y-axis. And we're looking at where these lines cross through them. So we go, okay, no problem. I see that the purple line crossed through right here. And that happens to be -4. So you want to write that -4 in the y-intercept place. You're very welcome, right? And you want to make sure You still have to solve for your slope. So that was stuff that we did on the previous slide, and use that here on this one, right? So this wouldn't have been as easy as we made it, but because it was a two-step process at this point, we already solved for the slope, and now we're moving forward to put it in an equation form. So that's just some extra stuff, just in case they ask you how to do it. I know some people have tests where they ask you to actually type in answers, things like that, so you just want to be careful. Yes, y equals 2/3 x is also an appropriate answer instead of putting the plus x. Number 2, I don't know, I love algebra, so I was in an algebra mood when I made this. So question number 2 says, how many solutions does the equation below have? So obviously you need to know some stuff before you can just like work out the problem. So does anybody by chance know the cool little chart that we should be using? Like if the two numbers are the same, how many solutions they have? If a variable equals a number, how many solutions they have? If they're not equal at all, how many solutions they have? Does anybody know that chart by chance? I know, I love reaching. Anybody? Okay, well, if you don't worry, I'm always going to tell you. I never not tell you. So before we even dive into the problem, let's look at potential answers that we can get. So if we have a variable, let's name that guy x, and it says that it's equal to a number, we're going to have one solution. If we have two numbers that are not equal to each other, number does not equal number, you will have 0 solutions. Okay, and if you have a number that is equal to the number on the other side, so like 4 is equal to 4, -7 halves is equal to -7 halves, you're going to have infinitely many solutions. So if a letter equals a number, if one letter equals one number, you have one solution. So it says that X or A or B or whatever the letter is, or pi or alpha or omega, whatever, is equal to 7. Then you have one solution. If you have two numbers that are not equal, like 7 is, it'll look like this, 7 is equal to 9. Well, they can't be correct because 7 is not equal to 9. You have 0 solutions. And if you have a number that is equal to itself on the other side, you will have infinitely many solutions. So you have to know this in order to answer the question, essentially, because you need to know if you have 1, 0, 2, or infinitely many solutions. So now we actually get to solve the problem. So I want to start by actually doing the problem, and then we look at our solution to figure out what's going on. Well, I see that the -5 is out here outside of the parentheses. And if you know me, what's the first thing we always have to do? We have to be fair and give it to everyone. So first things first is distribute the -5. That means -5 times x to give us -5x. -5 times a +2 to give us -10. Bring down the rest of that left-hand side. Keep the equal sign and continue. So now -3 has to go to everybody. So -3 times +2x is -6x, and -3 times a +4 is -12. Bring down the -2. Okay? We're not doing anything yet. We're not moving anything yet. We're going to look at the problem and we're going to see what can we combine on the same side. So let's go ahead and combine like terms, but on the same side, not across the equal sign. So I see that I have a -5x and I have a -x. I can put them together, combine them. And if I owe somebody $5 and I owe them another $1, I owe them 6, so I have -6x. Then I have a -10 and a -4, give me -14. Keep the equal sign. There's no other x on the right side, so I'm going to keep it -6x. And then I'm going to combine my -12 and my -2. to get negative 14. Okay, well, I'm not going to keep going, and I'll tell you why I'm not going to keep going. I noticed something. Have you noticed it? They're exactly the same. Do you remember what I said? If they're equal to each other, how many solutions we have? I don't know why I'm doing a little dance. I don't know. This is a good happy Wednesday. I should be hearing you all the way from New York, whatever you're screaming, and it should be infinitely many. So now you're probably staring at me going, well, I thought you said that if it was a number and another number, then it was infinitely many, as long as both of them are exactly the same. So what will happen if I decide to move the negative 6x to the other side? Let's keep doing. Let's keep working. I don't know why I said that. So let's go ahead and add the 6x. We're going to move it from the left to the right. All right, so now I'm moving it, and I'll have negative 14 is equal to, oh, look at that, negative 14, which is a number equal to the same number. Boom, wham, bam, thank you, ma'am. So why did I stop before I got to this step? Because I noticed that they were exactly the same. So if I had moved one piece to the other side, so let's just say I decided to go the other way. Negative 6x minus 14 is equal to negative 6x minus 14. Let's just say I'm going from the right side to the left side. If I add 6x, it's the exact same thing that I just did right before. So I do have the exact same thing on both sides, which is going to give me that infinitely many solution part here. So wham, bam, thank you, ma'am. The answer is D. So you just want to be careful. Questions before I move forward? Okay, we can always come back. Question 3, I know, another algebra problem. I told you I was in algebra mood when I made this, middle school and high school. So question 3, we see some steps that they're giving us. So they're probably going to ask us to figure out where an error occurred, right? Well, if we read the problem, we see that it says a student was given the following problem and asked to solve for G. So they didn't give us the typical X or Y or anything like this. They gave us this random letter G. And they want to know, in what step did the student make an error? So if we glance at our answer choices, we notice that step 1, step 2, step 3, or no error was made at all. Don't look at the steps first. We talk about this all the time. And if you have ever done tutoring with me, I always tell you, don't do it. That's me like being mad. Don't do it. So we don't look at the problem, the actual steps. We take the problem and that's it, and we work out the math ourselves. Why? Because you guys know way more math than you give yourself credit for. And then what ends up happening is you make a mistake. So first things first, you copy the problem, 4.5. I love the answers I'm seeing in the chat. Plus 6.5 is equal to 7.9. Okay, so I did the math. Let me write it out. We're going to distribute the 4.5 to both pieces inside the parentheses. I'll get 13.95G plus 29.25 is equal to 7.9. Okay, so I look at my step 2 and I look at their step 2. And we both definitely have the first part the same, right? This 13 part. But I, gosh, Dolly, don't know what they did, but we definitely did not get the second part. So we have to go ahead and say that step 2 is where, oh, not step 2, it's step 1, just kidding. Step 1 is where they made their error. It's the second line, but it doesn't mean it's step 2. Step 1, step 1, step 1, step 1, step 1. Step 1 is where they made their error. So yes, if you look at what they did, they actually just brought down that 6.5 and they didn't distribute the 4.5 to it at all. So you want to make sure that you do the math on your own, because what ends up happening is you start second guessing yourself and you go, oh, but do I actually give the 4.5 to both of those pieces, the 3.1G and the 6.5? Do I give them to both terms, or do I just do one? And that's where the confusion starts, and you don't want to doubt yourself because you're way smarter than you give yourself credit for. All right? Questions, put them in the chat. But let's keep going. Okay. Number 4, it's an inequality this time though. So it's not an equal sign. So it's like a different type of algebra. Shh, I'm lying to you. It's all the same. So which of the following values satisfies the given equation? So we noticed that I said it was an inequality. But what do we know about inequalities other than they make these great tongue twisters to figure out greater than, or less than, or greater than or equal to, or less than or equal to? I always tell everybody the same thing, and it doesn't matter how old I get, I'm always going to be like this, and it's just how I'm going to teach it. Ready? The alligator, the inequality, always eats the bigger number because he's hungry, right? So when we look at these problems, we always want to make sure that we don't, what don't we do? We don't mix up the words with what we actually see, right? So we look at the problem and we go, well, we can solve this a few different ways. We can plug and chug, and that means take our answers, plug them in, and chug out an answer to see which is correct, or factor. Well, I'm going to save you some headache, and I'm going to tell you that this is actually not factorable. So the only way that we can solve this is actually plugging and chugging. So that means that you have to start with whatever number you want to. I think people kind of like telling me to start with 2, so that's okay. We'll start with 2. Well, I'll do a number before 2. That should give you a hint. Let's do -1. So 5 times -1 squared plus 6 times -1 minus 15 is greater than 0. So you just want to do the math. Remember, PEMDAS, please excuse my dear Aunt Sally, right? But we want to write it this way, not in a straight line. So our exponents come first because our parentheses have nothing to do on the inside. So we're going to do our exponent, which is right here, and we're going to have -1 squared. So -1 squared is 1, and 6 times -1 is actually -1. So let's just do that part because we're there. Keep the -15 greater than 0. That is 1 minus 6 minus 15 is greater than 0. There is no way that these large negative numbers are going to be larger than 0. So unfortunately, -1 does not work. And you can keep going down the list. You can try 0, 1, or 2. But like I said, I saw some people yelling at me in the chat. Not yelling at me, I exaggerate. 2, 2, 2. So let's go ahead and plug in 2. Let's see what happens. So we have 5 times 2 squared plus 6 times 2 minus 15 is greater than 0. So we start with our exponent, and 2 squared is the same as 2 times 2. So 5 times 4 plus 12 minus 15 is greater than 0. 5 times 4 is 20 plus 12 minus 15 is greater than 0. 32 minus 15, I hope I'm doing my math right, is greater than 0. And that is definitely a larger number than 0. So at this point, don't even pull out the calculator. Don't hurt your brain and try to figure out what's going on. Just go ahead and pick the answer, because there is no way that 15 being subtracted from 32 is going to give you a negative number. Not at all. So our answer here is D. I don't know what they corrected that to. That was supposed to be a circle. And yes, we do offer private tutoring. We can talk about that at the end, right? So if you know that your math is good and you know what you're doing, so you're not doubting yourself, We want to make sure that we go ahead and select the answer and move on. Let's not waste time on things that we can be spending other time on, right? So you want to make sure that once you get to where you need to be, you just move forward, right? I don't need to go back and check 0, and I don't need to check 1. That's wasting precious time on that timed test, and it's taking away time that I can spend on other problems, right? So you want to be careful with how you're time managing. That's one of the key things when doing time tests. Okay, so I switched it up a little. I decided I wanted to do some probability and statistics today as well. It is a middle and high school level for sure. That's my last name, so it's my class. So question number 5 is talking about me, right? I know when you were little, if you ever saw your name or your friend's name in the problem, everyone got like super excited. So I make questions about myself to still have that little, little happiness while I'm teaching. So Miss Persaud's class was asked the number of museums they visited over the summer. Okay, that's great information, but that doesn't really give us anything to go off of. So we keep reading and we read that more than half of the class had not visited any museums. They tell us roughly 30% had visited 1 museum and the remaining students had visited 2 museums. So now they ask us the lovely question, which of the following is correct? Okay, well, I don't know what to do with this, so I'm going to take a look at the answer choices to figure out where I should be heading on how to solve this. So I look down at the answer choices and we see some really common words, and they definitely should be familiar. And if they're not, we definitely need to talk about how you're setting. So words that we like, that we notice: mean, range, mean, median, median, mode, median, and mode. So we're really looking for the mean, the median, the mode, and the range, right? And then we have to compare them because they're telling us is equal to, is greater than, is equal to, things like that, right? So we go back to the problem and we go, okay, well, I could totally figure out how to do the mean, the median, the mode, and the range. But in order to do that, I need data, right? Well, where's our data? We're used to seeing data like this. I'm just going to write the numbers down. Right? We're used to seeing stuff like that and then figuring out what the mean, median, mode, and range is. But we don't have any of that. So what are we supposed to do now? Well, we still have to create the data, right? So we're going to create the data, and then we're going to talk about what the words mean, because that's how we're going to solve it. So in order to create the data, we have to go, did they give us the number of students in the class? I reread it. There is nothing about how many students Ms. Persaud's class has. Absolutely none of them. So what now? Well, did they give us a specific number while we read through the information? Like, did they say 7 students did something or 20 students did something? I read back through the problem. No, we don't have that either. So now I ask you, what do? We don't have the number of actual students that are in her class, and we don't know anything based on actual information to give us a lead on how many kids she may have. So what do? I'm trying to write the answer, and my iPad is not letting me. So I'm going to tell you out loud instead of having a random surprise. So you're going to make it up. I know, I'm not making this up, I promise. But you're going to make it up. Okay, so let's ask. I don't know who Lex is, but let me ask you. How many students would you like to have in your class so you can make this data? Just 10. No more than 10. Don't make it more complicated. 10 students. I have 10 fingers, I have 10 toes. It hasn't failed me yet, and it's a good standing. Why do I say that? 20 is too much. You're on a time test. You don't have time to do 20, and you don't really have time to do 15. And why do all these like ridiculous numbers when 10 really is a good number to go with? So 10 is going to be your like default number, and this is why. 10 is large enough to give you accurate information, but small enough to be able to work with quickly, right? You are more than welcome to try this with 20 after we are finished, right? And see if you still get the exact same answers. And you should, okay? So I'm going to write 10 lines, not 20, 10 lines across the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are my 10 students. And now I'm going to read through the problem and do what they tell me to. So orange is going to be for my yellow, and it says more than half of the class had not visited any museums. So more than half. I don't know how much more than half is, but I do know how much half is. Half is 5. 1, 2, 3, 4, 5. And they didn't tell me how many more than half. So I can't assume too much, but it just needs to be more than 5. So we're going to go with 6 students had not visited any museums. So 6 students get zeros. I'm then going to keep reading, and it says that roughly 30% visited one museum. Well, I can't use 5 because it specifically says more than half. 5 is half, and we have to have a number that is larger than 5. Right? You want to be careful with what they say, because if it had just said half of the students had not visited any museums, yes, 5 is a perfect answer. No need to worry. Go with 5. But now it says more than half. So you have to go where half is, and you have to give at least one more. Don't make it complicated. Don't go like, oh, 1 or 2, maybe 3. Just one more means more than half, and that's all you need. Promise. So now we have to read the second part where it says roughly 30% visited one museum. Okay, but is it 30% of 4 students or 30% of 10 students? Ooh, you're going to get mad at me. It's 30% of 4, and I'll tell you why. We don't want to take it from the whole because we don't know that there are 10 students in her classroom. There could be 15, there could be 8, there could be 20, there could be 80. We don't know how large her class is. All we know is from whatever is left, we can continue moving forward on whatever they tell us. That's the best thing to do when it comes to problems like this. If you're making up the number of total, you cannot take the 30% from the whole because we don't know what the whole is. We only know what is left. So we're going with 30% of what is left. And if you do 30% of 4, you get like 1 point something, and you can't have a point something student. So we go ahead and just say that one student went to one museum, and the rest of the students went to 2 museums. Trust me, the more you see this and the more you read it, the more you'll understand it. So now before we get started on how to solve the problem, we need to know what the words mean. So can anybody tell me another word for mean? Average. Can you now tell me how to solve for the average? It's the sum of the numbers or the data divided by the amount of data. Okay, can somebody tell me what the median is? If for whatever reason you have trouble with this, if you think about it, hope everybody's a driver because I'm about to tell you something about driving. If you're driving in the road, on the road, in your car, on the road, in your car, and that thing in the middle of the road, it's like that concrete piece, the grass, what's that called? It's called the median. And the median is located where? In the middle of the street. So the median is the middle. So you have to have all numbers in order. So order numbers. And it has to go from least to greatest. So I'll just put least to greatest. And then you're going to look for the number in the middle. But what if there are 2 numbers? If 2 numbers, what do? You add the numbers together and you divide by 2. You take the average of the 2 numbers. So if we had 3 and 4, we're going to add 3 and 4 and divide by 2, and we're going to get 3.5. Right? Well, that's mean, median. Let's do mode. Mode is the most, right? So it's the number that you see the most. You can have 3 2s and 3 4s, and they both be the mode. So you can have more than one mode as long as it's a tie. And the range is the largest number. Oh, my pencil's acting up. Minus the smallest number. And that gives you the range, right? It's the range of the numbers. So let's go back, and we've got to figure out our mean, our median, our mode, and our range. So I'm going to do mean last because it's the most complicated. So get the easy stuff out of the way. Do them quickly. So I look at this and I go, well, I know my mode. Because remember, half of the numbers were 0. So if more than half is 0, then my mode is definitely 0. So my mode is 0. Mode equals 0. My median is the number in the middle. So cross, 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 cross. Okay, so we're left with 2 zeros. And we do 0 plus 0, or if they're the exact same number, remember that they're just that number. So the median is also equal to 0. So we notice, if you are the overachievers and you have already looked ahead, D is the answer we're going for, but we're going to keep solving for the rest of this. So we have our mode and our median, and they are equal. So let's find out what our mean and our range is. Our range is the largest minus the smallest, which is 1, and that's our range. And our mean is the sum of all the numbers. So 2 plus 2 plus 2 plus 1, all divided by 10 students. So 7 divided by 10 is equal to 0.7, and that is our mean. So the mean and the range are not equal. The mean and the median are not equal. The median is not greater than the mode because they're exactly the same. So the only one that we have left is D. Winner, winner, chicken dinner. Any questions? Oh, just kidding. The range is 2. I totally didn't do my math properly. Thank you for catching that, Sir William Ray. Okay, so Sir William Ray said, hey, by the way, what's going on? Why isn't the range 2? I totally did that on my paper, but I didn't do that on my iPad. So 2 is here, and that's the largest, and the smallest is all the way over here, which is 0. So our range is 2 minus 0. I greatly appreciate that. And it's still not the answer because it says that the mean is equal to the range, and they definitely are not equal. Thank you again. Any questions? Okay, these are definitely words that you need to know. So if you don't know these words, this is a great opportunity to make sure that you are writing note cards. You have to speak the math language. If you don't know the words that they're asking you, then you won't be able to solve the problem, right? So let's go ahead and do another probability and statistics problem. Oops. Okay, so Sue is doing a card trick for her friends. And they want to know what is the total number of possible combinations if her friends choose 3 cards at once from the 52 card deck without considering the order. What? Try that again. What is the total number of possible combinations if her friends choose 3 cards at once from the 52 card deck without considering the order? Well, because I made the problem, I know the problem, but your spidey senses should be going off and you should be going, I have 52 cards and I'm choosing 3. Does that sound familiar? 52 cards, choose 3. Does that sound familiar? Well, it should. It should lead your brain to this thing. n choose k, and that turns into a lovely formula of, I know this, n factorial all over n minus k factorial k factorial. Well, if you don't know what factorial means, I'll show you. So let's just say that I had 4 factorial. 4 factorial, that means exclamation mark. I would do 4 times 3 times 2 times 1. So it's the number that you have multiplied by every number all the way to 1, right? So if we do the problem that we're given, what is our total? Our total is n, which is 52 cards. And what are we choosing? 3. Yes, it looks just like a fraction, but with no bar. So let's go ahead and plug in what we know. I know that I will have 52 factorial in the top, and then I'll have 52 minus 3 factorial times 3 factorial. Okay, don't worry, we're going to get through this math. We're still going to have 52 factorial in the top, but now I'm going to do 52 minus 3, and I'm going to have 49 factorial. So now here's a really cool thing. We can write 52 all the way down to 49. And this is the cool thing that happens. 52 times 51 times 50 times 49 factorial. Because I don't want to keep writing the rest of them. So 49 all the way to 1. All over 49 factorial times 3 times 2 times 1. I'll just write out the 3 factorial. There's not much going on there. Cool thing here is the 49 factorial in the numerator and the denominator can now be eliminated because it's 1. Anything over itself is 1. So now we're just left with 52 times 51 times 50 all over 3 times 2. I'm not going to write the 1. So we're left with a denominator of 6, and you have to figure out what your numerator is. And according to my calculator, I had 132,600 in the numerator, 6 in the denominator. When you divide that, you get 22,100. Winner, winner, chicken dinner. So if you know how to read the problems, they're not that bad, right? But let's say you didn't know how to do this problem. This is definitely one of those where you just kind of close your eyes and pick a number, because I didn't really give you numbers that were too close together. Well, yeah, kind of. A, B, and C are kind of close together. So you might have looked at this and said, well, D is outlier. Definitely for sure, it's not like the rest, so I might not even choose it. But sometimes they want you to think that it's an outlier and it doesn't belong to the rest of it, and they want you to choose it. So you just have to be careful. Try to take estimated guess, educated guesses when you're doing things like this, but definitely don't leave it blank. Number 7, another probability problem. So it says that Marty has a bag of number cards. There are 10 cards in the bag numbered 1 to 10. So we're just going to write them out. 1, 2, well, try that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, there are 10 cards, and they do not have repeating numbers. That's good to know. He and 4 friends take turns choosing cards from the bag and putting them back in. So they're taking stuff out and they're putting it back, and they're taking stuff out and they're putting it back, and they're taking stuff out and they're putting it back. So the first 3 people choose odd numbers from the bag. Did they keep those numbers? No, because they told us that they take it out and they put it back, and they take it out and then they put it back, and they take it out and they put it back. So no matter what you do, you still are starting with the same numbers every single time. There's nothing that's changing. The question asks us, what is the probability of the 4th person choosing an odd number from the bag? So you have to know what odd means in order to be successful with this problem. And you have to know that you aren't keeping the numbers, you are putting them back. So odd is not even, and everyone kind of knows what an even number is. So it's just kind of like the opposite. So I'm going to circle all of our odd numbers. 1, 3, 5, 7, 9, right? Don't get them confused with prime numbers. 1, 3, 5, 7, 9, those are our odd numbers. They are not even. If I wrote 1 down, I do not have enough to give to 2 people. So we have 1, 2, 3, 4, 5 odd numbers. And how many in total? 10 in total. So anytime we're picking things out and putting them back, we always have to ask ourselves, well, how many times are we doing this? We're asking ourselves just about the 4th person. So we're only doing this once. We're only looking at that person at this particular moment in time. So our fraction is going to be the number that we choose, or the type of number we're looking for, over the total. Remember, our desired over the whole or desired over the total. Well, we're looking for an odd number, and we have 5 of them, and we have 10 cards in total, and we can reduce that by dividing the numerator and the denominator. It has to be the same number by 5, and we will get 1/2. So the probability of that 4th person pulling an odd card from the deck is half. The probability of half. They have half the amount of chances to do that. Well, here's a bonus question. What is the probability of choosing an odd card without replacement another odd card? So how many times are we choosing or pulling? How many times are we pulling from the bag? 2 times, 2 pulls. So 2 pulls tells us 2 fractions. We have 1 fraction multiplied by a second fraction. We're still looking for the desired number type of card in the top, and we still have the totals on the bottom. Now you ask yourself, what are your chances before doing something? So remember, we have 5 odd and 10 total. So before I put my hand in and I change it, I have the chance of pulling 5 odds out of 10 in total, which we learned that that could be reduced to 1/2. So I'm going to write 1/2. Now, without replacement means if I take it out, I'm keeping it. I'm not putting it back in the bag. So if I'm not putting it back in the bag, how many odds do we now have left in the bag? Well, if we started with 5 and we have 1 less, now we have 4. And if we started with 10 and we have 1 less, now we have 9. So you have 5 over 10 and 4 over 9. And I just redid the fraction of 10 over 5 because we knew from the previous slide that it's 1/2. It reduces to 1/2. So remember, when you multiply, you're multiplying straight. 1 times 4 is 4, and 2 times 9 is 18. And I can still reduce that by dividing both by 2. And I'll get 2 over 9. That is the simplest form that it can be. Great job, Sir William. Right, so here's another one. Let's try one more. What is the probability of choosing an odd card without replacement and even cards? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So remember, we had 5 odds. So how many evens do we have? We have 5 odd, and that means we have to have 5 even to get a total of 10, right? And now we're going to do odd, total, and even total. Remember, we're still reducing the number that we have. So we start with 5 odd and we have 10 in total. But if we pull out an odd and we keep it, we're only changing the total to 9. The evens, we still have 5 evens, and we still Now, well, we now have 9 in total. Well, we know that that becomes 1 over 2. So 1 times 5 is 5, and 2 times 9 is 18. All right, so little things like this are things that you have to pay attention to. If they told you without replacement, you have to make sure that you understand that you don't put that card back. You keep it and you don't replace it. But it's always starting at what do I have before I do anything? And the second fraction is what I have now, right? So you write the fraction how it would look before doing something to the bag. Then you do something to it and you now write that new fraction. And remember, you can only take one at a time. It's kind of like this unspoken rule that you can't just grab it all in one chance. You have to do it individually. All right. The next question is a little too long, so let's skip to number 9. Number 9's a little easier. It is definitely not a calculus problem. I apologize. So it says that Dean earns $23 per hour for the first 8 hours of a work day. For each additional hour he works beyond the 8 hours, he earns time and a half. So that's key to know. Time and a half, and this is his original for the first 8 hours. Then they tell us how much he made on his paycheck. $357 in a single shift. So they want to know what? They want to know how many hours he worked in that shift. First things first, we have to figure out how much he gets paid in the 8 hours. That tells me that I need to do 8 times 23. And my paper says 8 times 23 is $184. So this is what he made in his 8-hour shift. But he obviously made more than that, right? He made $357. So let's figure out how much money he had outside of his 8-hour shift. So 357 minus the 184. When we subtract, we get $173. This is with time and a half. Well, we have to figure out what the time and a half is, right? So time and a half is what he gets and half more. Well, what is half of 23? I know this. Oh, I don't know this. 23 divided by 2. I'm sorry, guys. I've just failed you. 11.5. Okay, so we have 11.5 that needs to be added, because that's the half part, to the time. So the time is 23. So 23 plus 11.5, so 1150. We will get 3450. That's his time and a half number. Time and a half. Okay, so if he gets 3450 for time and a half, thank you, I appreciate it. If we get 3450 for time and a half, what do we now do? We have to figure out how many 3450s we have in 173. Why? Because that will tell us the amount of hours he got paid for, right? So 173 divided by 34.5. All right, my lovely handy dandy paper says that that is 5 hours. That's his time and a half time. Okay, but the time and a half time is not the answer that we're looking for. I know I'm tricking you now. It's looking for the entire shift. He didn't work 5 hours in the shift. He worked more than that. And he didn't just work 8 hours in the shift. He worked more than that. Oh, I didn't put the right answer, did I? Well, we have to add the 8 and the 5. And we actually get 13 hours. So my answer is not even on there. So we're going to make an E because I'm crazy. And you guys are definitely laughing at me now. That's okay. Humans make mistakes. Our answer is E, 13 hours. All right, guys. Ladies and gentlemen, it is always a pleasure being with you. I know someone was asking earlier about one-on-one tutoring sessions, right? We do offer tutoring sessions here at the Learning Liaison. We also always want to thank you for everything that you do and showing up for these. Everything can be found on our website. There are more than just one tutor. We do more than just math, right? Just come on over to figure it out, see what we have going on over there. And anything you need outside of the personal tutoring, you can always use the discount code Pryia Math. But thank you, thank you, thank you. And you guys have a good night.